this video we are going to make sure that our player can't attack the skeleton when he's not facing the skeleton and when he's like not in line of sight of his target. As you can see here, if I would stand like this, I shouldn't be able to attack him, and also when I look this direction I shouldn't be able to attack the skeleton either. So how do we do this? Well, I think we are going to use something called Raycasting for figuring out if the player is actually facing our skeleton, or if he can see the skeleton for that matter. I think I'm going to create a new function here. It's called private bool in line of sight. So this one will return true if we are in line of sight of our target. So right now I'm just going to make it sure that it returns false, so that it doesn't give us an error. And then we can try to draw a ray just to see what we are going to do, because a ray cast is a thin line or a thin ray between 2 points. So we can cast an invisible line between our player and our target, and if that line hits our target, then we can see him, and if it doesn't hit the target, then we are unable to see him and we shouldn't cast a spell. So before we start casting the actual ray, we can actually try to draw it. Something called debug.drawRay, and we can actually use a start position and an direction to do this. So my start position is my transform.position, and the direction, well, the direction is the direction between the player and my enemy or the target. We are already generating the direction in my spell. When he's casting something, we are figuring out an angle and everything, and we're getting a direction here. And it's actually the same thing we have to do with our player, so he knows where to shoot the ray. And basically later we are going to rewrite a little code so we can get this direction right away from our target, but we will get to that. So let's calculate the direction here. The target direction is equal to the target. And how do the player get the target? Well, right now I don't think he has a reference to the target. See, it doesn't have a reference, but my spell has a reference to the target, and I am setting the target right here when I create it. So basically we're going to copy this code, and again, this is just for debugging, for testing now. Later we are going to get this by clicking on the target. I'm going to make a target here in my player, target equals GameObject.find target, and then I'm going to create a private game object called target. This is my target, and again, only for debugging purposes. Right now it's a game object. Let's make it into a transform. If I can spell transform, there we go. So I create a transform variable, and I add this code to my start function so that I will get this value populated with the target. When I've done that, I can go down here and say target dot transformed position minus transformed position dot normalized. Let's just do that. So now I have my direction like so. So I can use the target direction here to draw my ray, and I can write a color dot red, for example. So this in line of sight is only going to be executed when I attack. But for now, just for debugging purposes, we can go here to our update function and write in line of sight. Remember, we're going to remove this in just a second, so we're just going to test it. So if I play the game now, see that I can't see the red ray. And that's because I haven't enabled my Gizmos. If you need to see the ray, you need to go to Gizmos and enable it right here by clicking it, and if you still can't see it, you need to click the little down arrow and find whatever is missing and click it on, like so. So Gizmos will make it possible for you to see different things in game that you're not able to see normally, like cameras. So now you can see I have a ray here. Let's just maximize to make it easier for you to see. I have a Raycast here, and it's pointing towards my enemy at all times, right? So I'm simply going to use this ray to figure out if I can see my enemy or not. So I'm going to make some invisible colliders here, and if the ray hits those colliders, well, then I'm unable to hit my target because the colliders will be blocking the ray. Okay, so let's add it so that it makes more sense. So what are we going to use to block the direction or block the raycast? Well, we can go to our assets and create, and then there's something called sprite somewhere there, and there's something called a square. Okay, I'm going to add that square and call it block. Let's call it side block. This is my side block, and if I can add that to my game like so, then I can set it up so that it actually makes sense. This is just a box, right? So first of all, we're going to add a scale. Let's add it to 3.5. That's the scale there, and here I can make it 0.1 something, and Z is 1. That's fine. Okay, so that's one of them. I will need 4 of these so that I can block the view properly. And now I'll show you what I actually mean by blocking the view. So first of all, we need to rotate this one. Let's say, I think it's like 45 degrees or something. Yeah, minus 45 degrees. And these will be blocking my side. So whenever I turn, it will enable the correct blockers, so that, for example, when he's standing here, there will be a block there and one more there. If this one is rotated 45 instead, and then you will have another block. I need to zoom in to do this there, like so. Okay, so this makes sense. So when he's looking down, we will enable the blocks behind him, which means when I will be playing the game, he will be casting a ray into the actual block here, which means that I can't see my enemy. But however, if the enemy would be standing down here instead, then I will be able to see him, because the ray hits the enemy, it doesn't hit the blocks here. So we need to make sure that every time I turn, it enables some other blocks. So now when it did this, it will have to enable this one and one that goes down here. So let's try to do that. So when you have this side blocks, you can actually select them and put them as a child object of the player. And then we can right click on the player and say create empty, and call this new game object blocks, and put the side blocks in here. So yeah, I don't know if we should give them some names. The top one here, that's the right one. Let's call it, I don't know, top right. And this one, call it top left. And we need to take these two, and then we duplicate them like so. And then we'll have to select those two and rotate them 108 degrees like so, and then move them down here so that you have your player inside this square like so. Okay, so this looks kind of weird. It looks like some Viking drawings or something, but this is exactly what we want. We want him to be encapsulated like this. So this one down here is bottom left. And this one over here is bottom right. So now that we have put him inside this weird looking room, we can actually start to enable and disable them. So let's try to do that first of all. We will need to make sure that we can pair these up, because from the code we will actually have to do like this, right? Let's say they're all disabled, and then we look down, we have to enable these. And if I start looking to the left, well, then I will have to enable some others. Not like that though. Let's see here, bottom left. Yeah, if I start looking up, I will have to enable these two, so I can't see anything down here, and so on. And remember, you can always adjust these and make it more precise if you want to, exactly the way we want it. We're not going to be able to see these in game, so don't worry about those crosses here. But okay, we need to pair them up so we can enable them two at a time. And the easiest way to do that is to create a new script and call it block. So the block script will actually just contain an array of 2 blocks, and then it will use those 2 blocks to enable and disable them. So let's see here, we have the, where did it go? There. And the thing is, the script is not going to sit on an actual object in our game, so we're going to remove the mono behavior, like that. Then we're going to delete start and update, and we are going to serialize our block. So just delete system, everything except system up here, and then say serializable. Oh, it's a tag, of course, like so. So now we are telling Unity that this class we're going to create is serializable, which means that we can serialize it and see it in the editor. So actually we can just, if we do like this, I think we can see what's actually happening when we serialize it. So first of all, I'm going to make a private game object, right click, quick actions, and implement using Unity Engine if you don't have it already. If you can't right click, then just write using Unity Engine up here, because under Unity Engine we have the game object class, and this is going to be an array called blocks. This is all my blocks. So first of all, we need to serialize this. Serialize field, like so. So right now I can save this and I can jump to my player and say, well, the player needs some blocks. So I make a private blocks array and call it blocks. And then I simply serialize it like this and save it. So right now I save this, and if I go to Unity and select my player down here, I'm unable to see the array called blocks right here. But why is that? Well, I serialized it and it's just an array. It's exactly the same as up here. But the thing is, my blocks class here is not serializable. So Unity can't just serialize it and show it to me right here. So what I need to do is to go to my block script and comment this one in. So I have this over my class called serializable and save. So now when this is saved, I can jump back here and wait for a second, and now blocks pops up. So now I have the blocks here because my class blocks is serializable. And I have 4 outcomes here. I can go to left, right, up, down, and all those needs to enable 2 of these at a time. So my player needs to have 4, a size of 4 here. And as you can see, because each block has its own array, like this, right here, it has an array called blocks. Well, then under each block there is another array. And I could make this array like very large if I wanted to. And actually, I would only need 2, right? So I can actually do like this, private game object first, comma second, like so. So it has 2, right? So I can't make an array. That makes more sense. So now when I do this, then there's first and second under each of them. There's no point in making an array extra, because then I can have 10, for example. And I don't really need 10, I just need 2. So element 1, that's first and second. And the first one is always north. So that means I need to implement, or I need to take top right and top left. Or wait a second, actually I need to enable whatever is happening when I look up. So button left or button right, because if this character was looking up, I would need to enable these 2 down here. So these are the first ones, button left, button right. So I select my player, I select the first one, and I take bottom left and bottom right. The next one is if I look to the right. If I look to the right, then this one needs to be enabled without that one. That means top left and top bottom left needs to be enabled. If I look this direction here, it needs to block behind me here. So I select my player and I take top left and bottom left. This one is south. That means I need to enable these 2, this one and like so. If I look down, So I need to select my player and say top right and top left. So if I look to the left, my, let's see, bottom right and top right needs to be enabled features. And look this way, I'm blocking this behind me, so I can't see this character up here. So let's see, player, I need to take bottom right and top right. So now I have these elements in pairs, so I can grab one of the pairs and enable and disable them at the same time. I know this might be very confusing, but give me a second, it's gonna make sense right now when we start to enable them. So how do we enable them? Well, basically, if I deactivate them, let's try. If I say public void deactivate, well, we need to deactivate first and second, so we can simply just do like this. First dot set active false, second dot set active false. If I could spell here, like so. And then we need to enable them. So let's make a new function called activate and set them both to true. So now I can deactivate and activate a block, and a block is two of these lines we created. So then I can go to my player, and in here I can actually create a new function. Player, and let's make a new function down here. We have attack, we have in line of sight. After in line of sight, we can make a new function called block. This one will block the view for us. So for each is a loop that can run through an array, and we have an array of blocks up here, and we need to disable all of them first of all. When we disable all of them, then we can start activating the correct ones. So let's do that. So the first one here is called block, and this is my block. It's called B in blocks. Okay, so we are looking for the class block inside the array called blocks, and we are recognizing every time we look inside the array and we take up a new block, we reference that block with the letter B as a variable, right? So I can say b.deactivate to deactivate them. This will deactivate all of them when I start moving or whatever I do. And what do we want to call that? Well, we can call it when we actually attack. So in my attack function here, where is it? We have something called key down there. So right here, I would love to say block, like so. So let's test it out if we disable all of them. If we go in here and we just enable them all from the get-go, and I play and I press space, so when I press space they should all be invisible, and they are. So now we are actually disabling all of them. Okay, so now we can disable them. The next step is to enable the correct ones. So inside block here we will have to enable the correct blocks, and we can do that by saying blocks dot exit index dot activate. So the exit index already keeps track of the direction we are facing based on whatever we did in the last video. It will have the correct number, and based on that number we will enable the correct blocks. So if we put the blocks in the right order, this will fit. If we didn't put the blocks in the right order, well, then we have to change the blocks, because the exit index is set every time I click a key here. So when I press W, exit index is 0, and it will enable whatever is on index 0. So W is up, which means it should enable bottom left and bottom right. And if I look at the player, right here, blocks, first element, bottom left, bottom right. So let's try this. They're still visible and everything. So make sure when you play this now, disable all of them so you can't see them. And if you play now, it should enable 2 down here when I start press enter. And I didn't see them. Let's see here why. I think I might have forgot to save this. Let's try to save and jump back here. Let's try one more time. If I look up, there we go. Press space, it enables them. behind me. If I look here, it should enable 2 behind me here. There we go. And now when I attack, it should enable behind me there. There we go. And now it should enable there and there. There we go. So now we have this block thing set up so that we can actually block the right direction behind us. And as you can see, you can always make them small. Right now, I'm unable to attack the skeleton that is here. I will have to stand around here to be able to attack him. So if you feel like this line of sight we are creating isn't sufficient for your game, you can always make these smaller if you want to, so that it doesn't block as much. Because right now I'm actually not happy with the fact that I might not be able to attack the skeleton because this one might block it. But we will have to see what happens when we start using the block for something. So now we will have to rewrite our in line of sight and use it for something. We will have to delete this draw ray. This is just for debugging. We don't need that right now. So let's make a raycast. We can use a raycast by writing raycast 2D. Remember, it's 2D. We are not making a 3D game. And call this one hit. And let's say physics 2D is equal to physics 2D raycast. There it is. Okay. So where are we casting from? Well, we can argue we want to cast from our wand or our staff or whatever it is. But actually I would like to cast it from the center of the sprite because it's closer to the eyes of the wizard. It makes more sense. Let's just cast it from transform.position. This is the player's position. The direction, well, the direction is our target direction we just created before. So we want to cast it towards our enemy. And then we need a distance. How far are we going to cast this? Well, we are actually going to cast it by saying vector2 dot distance exit points. Or actually, let's take the player. Let's take player. Let's say transform dot position and the target dot transform dot position. So the distance between the player and the target. And as you can see here, this might be useful later when we need to figure out a range for shooting. Right now we can just shoot through the whole map, but later we might we will put in a range so that his spells doesn't have an unlimited range. So this might also be added to the distance. So if the raycast doesn't hit the target, well, then we're out of range, for example. So this distance might be changed. But for now, we are just casting it from the player towards the target. So if the raycast hits something, so let's say if our hit, because everything, if we throw this raycast, the information about the collider this raycast hits will be saved inside here. So I can say if the hit.collider is null. So if we don't hit anything, then return true. And why do we do that? Well, this raycast is going to be thrown towards the target. However, if it doesn't hit anything, then we can hit the target, because we're not going to hit the target with the raycast. We are going to see if we hit one of the blocks, which means if our collider hits a block, it's not null, and we should return false, which means we can't cast anything. However, if we throw the raycast towards the target and it didn't hit anything, well, then we need to return true because we didn't hit a block and we can cast our spell. So because of this, we can actually go up here to our attack and say and in line of sight. And I can do this because it returns a bool, a true or false statement, based on whatever it hits here. So what else? Besides that, we will also like to make sure that this raycast can only hit our blocks right now. It shouldn't collide with our player by mistake. So right here we can actually add a layer mask. So let's select our blocks here. If we go to Unity, select all the blocks and say layer and add layer here. And then under number 8 we can say block. This is our block layer. So when we have created that layer, we can select all of the blocks again and set the layer to block for all of them. Notice that it has index 8 here, which means I can make a raycast that only hits that layer. And to do that, I can go here and make a comma and say 8. So now this Raycast only hits layer 8, which means if it hits a block, it will return the information and tell you that you hit a block, so you can't hit the target. So remember to save this. So before a Raycast can hit anything, it will need a collider. So select all your blocks, click Add Component, and select a Box Collider 2D to make sure everything has a block collider on it, and just set them all to triggers. So if you enable them, you can still see them all, and you can see the screen line around this because we have a collider on it. So we don't want to see them in our game, we just want them to be invisible. So basically we can just remove the sprite renderer, so we can only see our colliders. And after that, make sure you disable the game objects so the colliders are also not showing. So if this works, then I shouldn't be able to attack my enemy right now if I press space. And I was still unable to attack him. So let's see what we did wrong. There's a few things that might be causing this not to work. First of all, inside our update we have this line called in line of sight, which we only should be calling when we press space, and I forgot to remove it. So basically we should delete this in line of sight code inside update. When we have done that, we need to take a closer look at the actual layer here, because we're using layer 8, and that's also the layer index when we open up Unity and open up the layers. But if we look here with the comma, you'll see that the overload here asks for a layer mask, and we can actually get the actual layer mask by going to update, for example, and say debug.log layer mask dot get mask, and then the name, well, we called it blocks or block, I think. So this is the actual name of the layer, so we can debug.log that and get the value. So if I do like this and play, I get the actual value here, which is 256. So if I take 256 and replace 8 with that number, we should get the correct layer. Let's try 256 and then save this and go all the way up here and remove the debug.log like so. Okay, so let's save and go back to Unity, and let's see. So now I definitely shouldn't be able to attack the enemy. And as you can see, I can't attack him. If I look up, I can. If I look to the right, I still can. So if I go over here, I can't see him. I'm unable to attack. If I turn around, I'm still unable. If I do over here, still. So you can see I can attack him here, but I can't attack him from here. And that's because of the size of these. So if you feel like the line of sight is not correct, or it's not like what you expect it to be, you can always select these and you can always adjust them in the scene. So that, for example, make all these shorter if you want to. Example, if I would go up here, now they're all enabled though, you can see it goes all the way up here. So to fix this, I would actually just take these out of play mode though, and select this and then move it down so that it makes sense, like so maybe, so that they are here instead. So you'll have to do that out of play mode, of course. So select them, select the move tool, move them down to here maybe, and down to here. So, and then do the same for the others here. But again, it's up to you where you would like it to cover and what you would like it to cover. Let's see here how it looks now. This one is a little further ahead than the other though. Now you can see now I can attack him here, but I'm unable to attack him here because it's blocking. So again, I hope you get the idea about how you should adjust this so that it works. And disable all of them. So I think between videos you can just adjust this and make it exactly as you want it. So thanks for watching this video. Thanks for watching my video. Please remember that InScope Studios is a community found page, so please consider clicking the support link on the screen to see how you can support me and get something back in return.